Although it may seem strange to look into the past, space researchers do so daily. The stunning images of the universe captured by the James Webb Space Telescope have provided us with an unforgettable year. These images allow us to observe distant galaxies in their pre-13 billion-year-old state. It is a propitious moment to be grateful both for our privileged place in the cosmos and for the ability these photos give us to travel back in time and contemplate the early universe, the birth and fall of stars, galactic mergers, and planetary atmospheres. The scientific discoveries of the James Webb Space Telescope are truly amazing and continue to break new ground. But how has this telescope enabled the observation of the universe's first galaxies? Which of these discoveries defy the laws of physics? Have we found any sign of life on other planets in the cosmos? Join us in this exploration to discover how the James Webb Telescope has revealed galaxies that defied modern physics. The speed of light is one of the best-known laws of physics that govern our universe. When we talk about light, we mean all the wavelengths of the electromagnetic spectrum moving at the incredible speed of 300,000 kilometers per second. Light moves so fast that it seems to happen instantaneously in our daily lives. However, traveling anywhere in the galaxy still takes some time, even at incredible speeds. When we stare at the moon, we actually see it as it was 2 seconds ago. Even if it's just a brief glimpse, it's still a glimpse into the past. The light emitted by the sun takes a little over 8 minutes to reach Earth. Our galaxy, the Milky Way, spans more than 100,000 light years, and the beautiful young stars that can be seen in the image of the West Carina Nebula captured by the James Webb Telescope are located at a distance of 7,500 light years away. In other words, the historical period represented by this nebula is about 2,000 years before the time when ancient Mesopotamia is supposed to have developed the first form of writing. Astronomers are constantly looking into the past, far from Earth, to see what things were like in the past. They use light that has traveled through time to try to piece together the mystery of our universe. With the help of space telescopes, we can observe parts of the light spectrum that are blocked by the Earth's atmosphere, such as the ultraviolet portions. The Hubble Space Telescope was optimized to work with these parts of the spectrum, while the James Webb Space Telescope was built to work with a variety of infrared light, allowing it to see even farther into the past than Hubble. Different wavelengths of the electromagnetic spectrum, such as gamma rays and radio waves, provide important information about the processes occurring in a galaxy. Recently, NASA shared some of the first images and data from the James Webb Space Telescope, including 4 targets that captured the infrared spectrum. President Joe Biden even shared a 4th image during a live broadcast, which shows a universe older than we have ever seen before. These images and data show the telescope's great potential to advance scientific research. 3 images captured by the James Webb Space Telescope show Stephan's quintet group of galaxies, the South Ring of Nebula and the Carina Nebula. The 4th target was focused on the spectrum WASP-96, where a gas giant exoplanet was observed. The Carina Nebula, located 7,600 light years from Earth, is one of the largest and brightest nebulae in the sky. It contains a supergiant star called Eta Carini that is on the verge of a catastrophic explosion. The South Ring Nebula, only 2,000 light years from Earth, is a planetary nebula that emits powerful ultraviolet radiation due to a white dwarf star at its center. The Carina Nebula provides new details about this stellar nursery and has made it possible to observe new stars that were not visible before. Newly discovered parts of the South Ring Nebula are also visible in the photos, along with the shells formed by the gas. Stephan's quintet is a group of 5 galaxies located 290 million light years from Earth. These galaxies are very close to each other due to their gravitational interactions. 3 of the galaxies have evolved to form elongated spiral structures, while the other 2 are in a cosmic dance that will eventually lead them to collide. The age of the stars in the group ranges from very young to quite old, representing hundreds of millions of years of cosmic history. While many images captured by the James Webb Space Telescope will be visually stunning, there will also be maps and graphics that may not be aesthetically pleasing, but will be equally important. NASA recently unveiled a map consisting of lines, dots, and squiggles that provide information about the distribution of dark matter in the universe. Although this map is not as visually impressive as the view of galaxy clusters or the image of the Carina Nebula, it is just as interesting, as are the many other graphics and maps that the Webb telescope will produce over the next 20 years. These images will enhance our ability to imagine what worlds far away from our solar system are like. Shown in the figure is a Jupiter-like gas giant exoplanet with details about its atmosphere. The exoplanet, called WASP 96b, orbits its star in about 3.5 days and is at a distance of 1,150 light-years from Earth. The temperature in its interior exceeds 1,000 degrees Fahrenheit, about 538 degrees Celsius. This planet, called WASP 96b, has been a mystery since its discovery, making it an area of great research interest. New observations from the James Webb Telescope have provided scientists with more information about this exoplanet's unusual atmosphere. By examining the starlight reaching the exoplanet's atmosphere, Webb was able to detect the presence of water and evidence of clouds on this incredibly hot planet. Clouds are quite unusual on WASP 96b because, due to its high temperature, rock can condense in the air like water does on Earth. But unlike on Earth, in WASP 96b, sand makes up the clouds. It has become clear that many other substances beside water can condense under the right conditions of pressure and temperature. Exoplanets will cease to be enigmatic cosmic objects and become real places in an extraterrestrial sky thanks to the James Webb Telescope. It is estimated that there are about 300 million habitable planets in the Milky Way galaxy alone, and several of them are only 30 light-years from Earth, making them humanity's neighbors in the galaxy. Before the James Webb Space Telescope was deployed, the most distant galaxy confirmed by astronomers was GNZ11. It was observed when it was approximately 420 million years old after the Big Bang, resulting in a redshift of 11.6. Redshift is a measure of how much a galaxy's light has been stretched due to the expansion of the universe. The farther back in time a galaxy is observed, the higher its redshift and the more distant it is. With the James Webb Telescope, we will be able to observe galaxies even farther back in time, up to about 100 million years after the Big Bang, which occurred about 13.8 billion years ago. Although light from these distant galaxies has been traveling towards us for billions of years, the galaxies themselves are now some 46 billion light-years away from us due to the expansion of the universe. This expansion is driven by dark energy, which is believed to be a universal constant acting throughout space-time. As the universe expands, dark energy has a greater impact on the expansion. This means that although the universe is 13.8 billion years old, its current size is about 93 billion light-years. Now, dark energy cannot be observed on a galactic scale, but its effect can be seen at much larger cosmological distances. I hope you liked the video. If so, hit the like button and subscribe so you don't miss more content like this. Thank you so much for watching the video, and I'll see you in the next one.